Good afternoon, everyone. The topic for discussion today would be DevSecOps, what, why, and how. Uh, Before we get started, can I just have a quick show of hands? How many of you are developers here? Okay. How many of you are sysadmin or similar profile? All right. Anyone pen testers here? I'm going to be cribbing about pen testers. All right. So before we get started, a quick introduction about myself. I'm Anant Srivastav. I started my career as a system administrator, did a bit of development, and now I'm full-time into information security. I like contributing and creating open source projects. So there are a bunch of open source projects that I've created, and I keep contributing to various open source communities. The details are available on the website that you see. I work for a company called Not So Secure Global Services. We're a boutique consulting and training firm. Based on our interactions and engagements with various clients, that's the reason why we basically moved into DevSecOps, because we felt that there is a need to have security in DevOps cycle. So the agenda for today would be to understand what is DevSecOps, why do we need it, how do we do DevSecOps, what are the pieces that is going to put together and form the whole DevOps. And there are some sample case studies around it. So a quick disclaimer, any tool that I'm going to be talking about, because obviously there's a lot of automation involved, so I will be using a lot of tools. I am not suggesting that you use that specific tool only. Everyone who has ever worked with anything related to IT would understand every single organization will have a different process, different flow, different requirements. You will have to test and see what works in your environment, in your process. So use what you feel is right. So I'm not endorsing any tool, but I'll still have to talk about tools, show a lot of tools. With that disclaimer done, let's try and see what is DevSecOps. This is one keyword which is thrown a lot around. If you try to get to the core of it, it is basically an effort to be secure by default. How do you achieve that state? You achieve that by integrating security in your tool chain, by creating security as code culture in your organization, and by promoting cross-skilling of resources. So if your dev knows ops, you get DevOps. But if your DevOps person also knows security, you get DevSecOps. Now, why do we actually need it? And this is very recent stuff that has come up. Earlier, waterfall model used to be where you will gather requirements, do a bunch of stuff, and after 1 year or 2 years in the pipeline, you will get the product out. But now when you look at it, web application development, we are looking at deployments, maybe 100 deployments in a single day. Anyone who is a pen tester, would you be able to handle 100 iterations of an application in a single day? The answer would be no. I need at least 100 days for 100 applications. That's where security is not keeping its pace. You need to get to a point where security is an integral part of the process. You're not treating security as an end point, but rather in the process you have it. So if I put it in a diagrammatical view, this is what is the conventional DevOps. You have the whole process, and at the end of it, you do pen testing. What if you change this process with at least one new change? You add an automated source code review tool. And for example's sake, let's say there was an SQL injection, which was earlier detected at the pen testing stage, but is now getting caught at the build level. You have not got any new vulnerable builds deployed. You have figured out that there is a problem. Your developer got the notification. They don't have to feel embarrassed against a security person who's basically bossing around that, hey, I found a flaw in your code. They know about it. They were able to fix it and move forward with it. That's the power DevSecOps provide to an organization. Now, the important question that comes up is, how do you achieve DevSecOps? So there are two aspects of it. There is automation and there is a cultural change. The conventional way of following and doing security or the entire DevOps is not going to work with DevSecOps. You'll have to do some cultural changes. I am not going to focus too much on the cultural aspect. There will be only 1 or 2 slides around that. My major focus is around integrating security into your DevOps pipeline. Now, what I've done here is I've taken the DevOps pipeline, a standard DevOps pipeline, and for each of these sections, I have added the security in the blue boxes. So for each of the section, multiple security checks, security processes that can be integrated are added in there. And right at the bottom that you see vulnerability management. So we'll be running a lot of tools. So we need a central dashboard where we can see all the results aggregated at one place. Now, instead of just talking through each one of them, what I've done is I've basically created a simple flow. So this pipeline that you see is a standard DevOps pipeline, enhanced, enriched with sec in various sections of it. So instead of just talking through it, what I'll do is I'll run a video, and this video should help you in understanding the whole flow. So you can see various stages that we have added for security within the DevOps pipeline. So you can see this was the DevOps pipeline on the top, which is now added, enhanced with the security integrated inside it. Now let's look at each of these sections in much more detail. So I'm going to be talking about 6 stages that we have added. The first is pre-commit hook, or what I like to call stopping developer from shooting themselves in the foot. Like in this particular example, developer was about to commit a private key in the code repository. Before the commit happens, my pre-commit hook basically stopped the developer that, hey, something is wrong. This file is not supposed to be committed in the code repository. Allows the developer to fail, but fail within the environment, fail early, move forward with the understanding that, hey, I did something wrong. Now, talking about the pipeline, the first thing that I would like everyone to think about is the software composition analysis. Now, at this point, I've pushed the code and I've ran a basic dependency check analysis. What I'm looking for is whatever my source code is doing is one part of it, but with the whole DevOps process, we have become too much reliant on third-party modules. So what those third-party modules are bringing to the plate, like for example, in this case, 38 high severity vulnerabilities added because of the third parties that we are using. So if the developer figures out what's wrong, tries to fix the code, like in this particular case, we were using a vulnerable version of struts. We moved to the latest in that particular chain, and we again committed the code just to see what changes. So from the earlier of 27 high, we are right now at 5 high vulnerabilities. Although we have not reached 0, but we are still considering this as an improvement and we are moving forward with it. The second stage is about static analysis. So in this case, we are using Java application, so I'm using findsec bug. Again, the build failed because there was one high severity vulnerability that we detected. So again, we'll have to go back into the source code, try and fix that bug. Once the bug is fixed, then the build will proceed. So at this point, we've identified the vulnerable code, fixed it, added the code which is working properly, and then we are again pushing things. And this time you can see the build was successful because there was 0 high severity bugs. If you would have realized, I am not looking at getting 0 as this vulnerability count, because achieving 0 is not going to be practically possible. So there are going to be some vulnerabilities which you'll have to ignore or accept as possible risks. So now comes the fourth stage, which is the dynamic analysis. At this stage, we have integrated OWASP Zap, and we are running Zap scan. Now, this is the first time you're seeing an email notification. What changed between stuff before and now is all the other tools that I'm talking about are quick and fast. They will work in like 5 minutes, 10 minutes max. Zap, on the other hand, is a beast. It will take 15, 20, 1 hour, 2 hour, 3 hour, whatever time it wants. It takes its own sweet time to finish. Once it's done, it will send a notification back to me that, hey, this was the result, but I don't want my pipeline to be halted for it. That's why no pipeline halting, but rather just start the scan and then wait for the email notification to give you an update if there is something wrong. Now, with the whole DevOps in process, the other advantage that you get is your code becomes, your infrastructure becomes code. When you have infrastructure as code, you can do scans on that infrastructure as code script. That's what we're doing in the infrastructure scan part. We're using DocScan as well as we're using Clear. Clear is a tool which basically does an audit of the Docker images. So we have our own Docker registry, and Clear is running scans on the Docker registry. And then to complement the, say, vulnerability scanning, we're using OpenVAS for it. So again, for OpenVAS, we will start the scan. We will not wait for it to finish. We will get the notification on the email that, yes, this scan is finished. This was the result. Now, a lot of us will have to deal with compliance. So when you're dealing with compliance, you can leverage tools like Inspect, and there are a whole bunch of tools which can help you in writing the compliance as code. And then those reproducible checks would continuously be running in your environment, and you will get the details. Hey, I am failing these many compliances. At times you may not want to have full compliance, but you at least want to know the status. I am compliant or not. That can be done with tools like Inspect, which is what we've run here. And in this case, 1 success, 21 failures. So we were running it in a Tomcat container, which was not securely configured. So a whole bunch of issues that it picked from CIS benchmarks. Now in our pipeline, we have basically an approval process to approve, and then the production deployment will happen. So once a production deployment has happened, we also want to place a WAF in front of it, which will help us in preventing some of the attacks. Like for example, here we had a SQL injection attempt on the login page. It got detected by WAF, WAF blocked it, and we got a notification. Again, depending on your environment, your scenarios, this WAF notification might just be a notification, no block, might be a full block, maybe IP ban, and maybe you can proceed further with it. So that's the notification that you got from the WAF. Now, if anyone had noticed, whenever I was running any of these scans, I was basically using a CLI, Archery CLI. What we were doing was we were basically leveraging a central vulnerability management tool called ArcherySec. This was demoed earlier today in Arsenal. It's an open source tool that we are using. So this tool will allow you to aggregate the whole set of options, sort of scans that you have run, be it these network scan, be it source code review tools, static scans, compliance scans, all of them can be aggregated into this particular tool. So this allows you to have a centralized view of what is going on in your pipeline. So I wanted to give an idea that, hey, the tools are not the problem. It's not that the tools are not available. What you're seeing right now is the list of open source tools. I wanted to be vendor agnostic. So all the tools that you see here are all open source or free tools. Either they're freely available for use or they are open source. So you can see for each of these sections that I talked about, right from threat modeling to pre-commit, software composition, static analysis, IDEs, secret management, to vulnerability management, dynamic security analysis, infrastructure scan, compliance as code, WAF, every single item that I've talked about, there are at least 3 to 4 different alternatives in the open source market. If your company does not want the open source stuff, you want a service support, whatever, each of these have their own set of custom software style. Vendors available, they will provide you support, they will charge for it, but they'll provide support. So that option is also available to you, depending on what works for your organization. Now, an important question that comes up is when you're talking about all these tools, You have to understand not everything is made to be just integrated into the pipeline. You can't just take every tool and just push them in the pipeline. These are some of the basic ideas that I have about what tool can go inside a pipeline. They should have API or command line access so you can initiate them automatically. They should be finishing the entire execution cycle within 15 minutes. That's kind of the sweet spot. After 15 minutes, if your one stage takes more than 15 minutes, that's when you start getting agitated. You don't like waiting that much. So 15 minutes is kind of the sweet spot, preferably 10 minutes max. Each stage should have that much maximum execution time. They should be containerizable, they should be scriptable so that you can work with them in any environment that you have. If you're going with something like a proprietary software, you may have to look at what kind of licensing limitations you have. For example, you may be using a vulnerability assessment tool, which has a limitation that it can only work for 100 IP addresses or for only 20 URLs. So you'll have to keep an eye on that. The output format should be parsable. You should not be relying on tool which just burps something out on command prompt and you're done. You should be looking at a tool which gives you output in the form of say XML, JSON, which can then be parsed by another tool to be processed further. Now, one thing that I did not talk about in the entire pipeline was about cloud. Now, you can't take cloud out of DevSecOps or DevOps in general, but with cloud, there are two threat landscape that emerges. One, around identity and access management. Those who are pen testers here, if you have ever encountered cloud, do you agree with the fact that, hey, identity and access management, APIs, tokens, these are the primary targets for a pen tester? The other attack that comes up is the billing attack. With on-prem equipments, if someone was running a crypto miner or XYZ high resource consumption tool, you were not worried about it a lot, because you are anyways paying for that hardware. But when it comes to cloud environments, if they are starting an instance or they're utilizing 100% of your resources, that can translate into higher billing charges. So that's another concern that comes up when you're talking about the cloud environment. Another advantage, again here, because we are doing DevOps, we are already at the level where we have infrastructure as code. So you can do linting, you can do auditing, you can look at what kind of security groups are configured, what kind of permissions are configured, and make a constant vigilance around them, which will help you in understanding if something wrong happens. How can you do that? There are three tools that I've mentioned. Security Monkey right at the bottom is a continuous monitoring AWS scanning tool. Scout Suite allows you to look at AWS, GCP, and Azure environments. CS Suite is one of my favorites. I have a bias because it's created by a friend of mine. With CS Suite, you will be able to run not just Scout Suite, but a whole bunch of security scanning tools related to cloud and get aggregated results out of it. Now, besides the technical aspects, just a quick touch base on the cultural aspect. Automation alone is not going to solve the problem. If the person sitting behind has no intention of going ahead with the DevSecOps culture, you will not move forward. The focus should be on collaboration. So far, security has always been that child sitting at the corner pouting that, hey, you are not doing the job rightly. That is not going to work with DevSecOps culture. With DevSecOps in place, you have to get involved with everyone else. I like to believe that the idea behind DevSecOps is the need for security person gets eliminated or close to being eliminated. The dev and the ops should be self-sufficient. They should not be requiring a third person for constant security advices. If there's anything critical, anything very complex, then yes. But day-to-day activities, if you're requiring a separate security input, you're doing it wrong. Now, how do you go about doing it? You encourage the security mindset among other teams. You try and build allies. Security champions is the keyword that everyone uses. And you avoid blame game. You avoid finger pointing that, hey, you did something wrong or I did something wrong. Now, how do you go about creating those security champions? You try to create bridge between DevSec and Ops team. It could be one person per team who is acting like a security champion. Those people basically act like a liaison inside dev team or ops team from security side, and they champion the security initiatives. Or what you can do is you can cross-skill everyone in the team. Another approach that I've found working in a bunch of different places is encourage others. So a security team can basically incentivize others to basically get security. Like for example, open up internal bug bounties. So your developers can submit bugs and then can submit fixes and they get paid for it. Or you can sponsor interactions, you can sponsor cross-skilling. So if a developer wants to learn how to do secure code development, that money, instead of taking it out of the dev team's pocket, you sponsor it from the security team pocket. And believe me, that will be a much better investment than training your pen tester. Because a secure code would eliminate need of a large-scale pen testing. Now, couple case studies that I've outlined. This is a very, very generic idea about how DevSecOps could help in scenarios. In this particular example, we have the DevOps pipeline and we have struts as a vulnerability which came up in May. And we have manual pen test happening somewhere in end of June. So that's when the bug will be discovered and the bug will be fixed. Now compare it with a DevOps pipeline where struts vulnerability was discovered somewhere in May. Immediately next 1 or 2 days, your software composition analysis tool gets an update that, hey, this version of struts is vulnerable. We should be looking at fixing this. And you immediately get the idea that, hey, something is wrong, we need to fix this. The moment you fix it, the bug is fixed here and you did not have to wait 2 months for getting the fix sorted. Now, couple of public examples, like in this example, this is a 2019 example. There were 24 million financial and banking documents available on an Elasticsearch database for 2 weeks without any authentication. What went wrong? Unaccounted, unmonitored asset. How it could have been prevented? If you had a recurring asset inventory and you were doing automated assessments on your assets regularly, someone would have picked it up. Another example, Snapchat. Someone committed the GitHub token on GitHub. Again, prevention, pre-commit hook can prevent similar scenarios. API keys, secrets, when they are getting pushed, pre-commit hooks could have been one way. Continuous repository monitoring could be another approach where you monitor all the public repositories, not just for the organization, but for all the employees of the organization. Because what I've seen is public repository of an employee, or rather the personal repository of an employee, leaking credentials, leading to organization compromise. So all that can be done by continuous monitoring. Now, this I could not find less number of S3 bugs. So this is Booz Allen Hamilton, WWE, Dow Jones, bunch of other companies, everyone with various S3 related issues. Cloud asset misconfiguration. All you needed to do was continuous cloud monitoring. The same set of tools that I talked about, if you have been running those continuously, you would have got an idea that, hey, something is wrong, I should be looking at it, I should be fixing this. Now, this is another interesting example. A Jenkins instance is exposed publicly, leading to compromise of the source code of the application. They had no idea that particular server is listening publicly, and then they had the source code available on it. Again, if you would have been patching, if you would have been continuously monitoring, this thing could have been detected earlier, prevented earlier. Now, I've been talking about DevSecOps could do this, could do that. This would be the silver bullet. It is not going to be the silver bullet. What you need to understand is DevSecOps is going to be a continuous process. Every time you do some changes, you again need a feedback to understand whether your change was actually successful or not. How you can get the feedback? Continuous pen testing, or what is the newer hip stuff, continuous bug bounty. Any bug that gets detected in a pen testing or a bug bounty, that is a feedback trigger for you. Somewhere your process failed. what you could have done to detect that bug in your process even before the deployment happened. If you can figure that out, if you can start putting that in the pipeline, you're saving yourself the trouble and you are improving your pipeline. Another thing, and this is very, very specific to corporates, risk acceptance documentation. Some people call it RAD, some have different names for it, but at the end of it, it basically means a security person goes in, hey, this is wrong. The other person comes back, hey, see this document? This says I am allowed to do this. I don't give a damn about what you think. Risk acceptance should be the last resort, not the first resort. Generally, what I've seen, to save time, people first prefer doing risk acceptance, then they think about anything else. Now, I've given 5 screenshots at the bottom. These are 5 different organizations. All 5 of them claim to be following DevSecOps by the letter and doing it efficiently with a lot of passion. But they still run their own public bug bounties. Why? Because they want that continuous feedback in the system. So these are a couple of references that I've used while I was preparing this whole deck. And just the last one. So the key takeaways, if you have to take, is just these 3. Security is everyone's responsibility, not a sec person, not an ops person, not a dev person. Ideally, it's one whole profile and it's your responsibility. You have to embrace security as part of your process. If you don't consider it part of the process, you will not be able to reach a level where you are secure by default. And accept the fact that if there are 100 DevSecOps professionals sitting together from 100 different organizations, each one of you will have a slightly different, tweaked approach towards achieving the same goal. It does not matter if one person is able to achieve certain things. You do what your company is able to sustain. You do stuff that is possible within the realms of your organization. Don't just aim for achieving XYZ blind targets in the wind. Focus step by step on improving your own quality. So I think that's about it. I'm open to any questions anyone has. I'm not sure how I'm doing with the time. Do we have time for questions? 3-4 minutes for questions. Yeah. Back one slide. Yep. It's an old black hat presentation. You'll find the video of it also. And hopefully by tonight, the whole slide deck would be up online. Yeah. You'll have to speak loudly because we don't have mics. Yep. So essentially, if I get it right, the question that you have is, how do I know whether my DevSecOps is actually making any difference or not? So So the problem with that approach is you are considering attack as a vector to define whether your process or your application is secure or not. That is going to be a factor of, are you even a juicy target for someone? You may have an insecure application, but you're not a juicy target, so no one cares about you. Assuming I am a valid target, So what you need to do as or from a higher ups perspective, what you need to look for is, if you are able to implement DevSecOps process, again, does not means that you have to go through the entire DevSecOps process in one shot and then move forward with it. Generally, the approach that I suggest is, instead of just saying, hey, I want to buy 100 tools, integrate all 100 tools, there will be these 2,000 reports, these 500 page of documents everyone has to read. Does not work that way. What you need to do is, you need to start small. Maybe start with a very basic idea. What kind of bugs are being found in your application in general? Let's say, so again, the experience is going to vary. Every company will have a different experience. Every organization, every deployment will have a different experience. What I'm talking about is, how can you start and show the efficiency is there or not. So if you say, for example, your applications are getting a lot of XSS bugs, or let's say a lot of SQL injection bugs, you take one class of bug and try fixing it. If you found 100 instances of it in a very basic source code analysis, like for example, let's say a PHP application, you're looking for SQL injection strings, you're looking for MySQL functions where get parameters or post parameters are directly inputted. If you can just figure out these patterns and you're able to isolate them, that is your productivity matrix, that, hey, by just adding this one check in the process, I was able to detect these, which could have resulted in a database compromise. Now, what is the value of that data or the database? That's something you have to quantify from your environment. You could have the actual bank application, or you could have just a small application which allows you to play raffle. So depending on what that data is, you make the call around that. Does that kind of gives you an idea? All right. I can't give you a percentage number. So that's why I said. So the problem that generally comes up is, how do I find the budget? How do I quantify the budget? How do I, the skill set also. The thing that you need to understand here is, start minimal, show profit, and then use that to move forward. Like the example that I gave, you can start that example by using grep. Now, grep as a tool is available everywhere. Does not need upskilling, but you can start from there. Start from a very basic, figure out one thing, show potential, then move forward with it, because now you have proven that there is potential. There is something that can be done. Anyone else? Any other questions? See, the bugs that you found first instance were the bugs in the dependencies. Static code analysis may not be able to look inside your dependencies. That's why it is not finding those bugs. So only the third-party dependency tracker can actually look for, okay, there's a jar or there's a compressed object which is of this particular version. This means this is vulnerable to XYZ flaws. That's how we are getting that data. So in this case, all the jar files, the tool is looking for what versions of jar file are there or the checksums, and then based on those, what type of CVEs are present. So that was detected. I intentionally left it at 5, not bringing it down to 0, because a lot of times you may have high severity CVEs may not be directly applicable in your environment. Like for example, you may have PHP server that has some high severity bugs for this particular version of PHP if a certain module is enabled. In your environment, that module is not enabled. You don't have to worry about fixing that particular scenario. That is why a lot of times you will have to do that trade-off, that risk acceptance document I was talking about. This is where it comes into picture that, hey, right now there is no point spending efforts in this particular scenario because it is not going to give me any result at all. So I'm accepting that these CVs in my code is all fine because they will never be exploited. But the moment they become exploitable, you go ahead and fix those. Right? Does that answers? So these software composition analysis, these are the tools. And you have a whole bunch more. All right. Can you repeat the question again? There are a lot of false positives. Yes. First is, and second, static analysis and dynamic takes much more time. Yes. So two different things here. One, lots of false positives. The other is the tools taking a lot of time. For the false positives, this is something which is kind of a pet peeve of mine. When you talk about static tools or dynamic analysis tools, generally we test it once. We figure out, hey, this is churning out 500 pages of report, 400 of it is crap. I don't want to deal with all of this. We stop at that point. Any static analysis tool will be giving false positives in first 2 or 3 iterations. After the first 2 or 3 iterations, when you've marked those false positives, you have tweaked the tool as per your need, that's when you start finding the actual bugs. So you'll have to take that effort initially to reduce the false positive. And that's one of the points, if you see here, configurable to counter false negatives and false positives. There should be some configuration available where you can look up, okay, yeah, this is false positive, I don't want this to be reported. Or this is false negative, this needs to be reported. That is something that you'll have to look for. Now about the time. So time could be another factor where you can look at 2 different approaches. One, like what we did in this scenario, we basically started the scan and then we did not pause the pipeline, we let it go through. The QA stage will be deployed. At that point, once the scan is done, I will get an email back. Hey, this is what happened. Now the email is a sort of representation here. It could be a Slack notification, could be pager if you are still using it, but whatever notification media you have, you can get a notification there. The other approach could be, you can tweak the profile that you are only concerned about, say, SQL injection and XSS, no other bug. You can tweak the scanning profile to only look for these 2 bugs. Nothing else, because that would need manual intervention. So I'm only concerned about these 2. The tweaked profile only looks at these 2 bugs and move forward. So that would be much faster. Yes. That's where you come down to the vulnerability management tool, which allows you to aggregate all of these, mark false positives at one place, give you a pictorial view, give you a stats around various builds, what is going on. You can also then trigger around what is critical for you. So if something critical comes up, a human is required. Otherwise, the machine will keep handling the data. And if something is alarming, suspicious, that's when you step in, you look at just that bit and move forward. Right? All right. Thanks a lot, everyone, for attending and staying a bit late. Have a nice evening, everyone.